Hello everyone. In the last lecture, we talked about some of the applications of big data. We talked about how healthcare is using big data. We talked about the academia and the education institutes, how they are using big data. And we talked about the banking sector, in particularly how big data is used to avoid the frauds which are taking place all across the world. Moving on, today we talk about four other use cases. One is manufacturing, IT, retail, and transportation. Talking about manufacturing, according to TCS Global Trend Study, the most significant benefit of big data in manufacturing is improving the supply strategies and the product quality. So, when we talk about the supply strategies, we are talking about the supply chain management. In the manufacturing industry spread all across the world, we have different manufacturing companies who are specialized in manufacturing a particular component, and in the end they will go to some other country where their taxes and everything is low. Over that place they will establish an industry. All of the parts from all over the world will be bought in, and the final product will be assembled, right? If we talk about Apple, all of these stores are in USA. The products, the iPhones and iPads, they are assembled in USA. The individual parts, maybe camera is made someplace else, display is made in some other company. All of the other components are broken up and dedicatedly assigned to individual companies who can make it, right? And from those companies we are getting lots and lots of data, right? If I am the owner of the Apple and I want to increase the quality of my camera, I am going to take up lots and lots of data of how it is being made, how many cameras have been launched, what is the specification, which camera type gave me better pictures, gave me better data. So everything is mined, everything is analyzed, and the key benefit lies in supply chain management, because when you have scattered components, right, spread across the world, how you are going to maintain and ensure that components reach in time at a particular place. So what can happen if I estimate, if I predict that the next year 1 million iPhones will be needed in the market? Accordingly I can predict how many spare parts do I need. If I have the database of the defected components of the iPhones which crashed, and the cameras and integrated circuits and processors which need replacement, if in a particular batch 80% of the processors failed, according to those failures I will have to order my parts in advance. If I do that, if I apply that prediction, then obviously my time to deliver the service to the people, to my users, that time will be shortened, it will reduce, and that will increase the performance and the quality of my business as a whole, right? So in supply chain we predict what will be the demand of a particular product, of a particular component, how fast and how in an optimized manner, how can you transfer the components, how can you achieve that shift, so that your company performance, your product performance, and your overall performance is increased, it is enhanced. And with regard to the quality aspects, you take in data, you dig into it, you find out what is the particular flaw which is making its performance go down. What is it? So you analyze it with the basis of, with the help of data which is present with regard to your components, with regard to your supply chain management, and again it comes down to the practical implementation. What are your objectives? What do you want to achieve? With respect to that objective, you collect and accumulate data. On that data, you apply your questions to find out the predictions, the implications, the interconnected nature of the different parameters which are present. Right? There you use the big data technologies to find out meaning from that place so that you can use it in your business. Second point In the manufacturing sector, big data helps to create a transparent infrastructure, thereby predicting uncertainties and incompetencies that can affect the business adversely. So if you have database ready at your hand, you can use predictive analysis to find out where are where your components are failing, what are the particular incompetencies of your business, how certain you are with regard to the success of a performance, how uncertain you are with regard to the launching of a particular product beforehand. Like what are your predictions with respect to the launch of the product, what are your predictions with respect to the that missing that component which is not performing well, what will be the implications of using that component if you do it under a resource crunch or under a business crunch. So those questions, those scenarios which normally we would have to actually do it to find out what is going to happen, but now we can simply simulate it and we can understand what is going to happen so that we are able to make a better choice. Other use case is of IT industries. IT industries across the world, right? They are using big data to enhance their functioning, to optimize their functioning. They are using smart modules, smart training modules, learning modules. They are analyzing the customer data, the customer behavior data, how a customer is performing, how an employee is performing, what particular data must be supplied to the customer, what particular training must be supplied to the employee when a particular employee needs support, right? Maybe considering the family background, considering the family conditions, there are many factors at play. And when we incorporate the big data technology into IT based services, into human resource management, we can find out and better our services, right? We can minimize the risk in business operations because we will be knowing, we will have we would have predicted what is going to work, what is not going to work. We can enhance employee productivity by finding out how many hours the employee is sleeping in the office and how many hours the employee is dedicatedly working on the system, what are the particular patterns which are emerging within the employees performance and the workload, what type of workload is suited and suitable for which type of employee. Classes can be made, segregation can be done, productivity can be enhanced, training can be provided. Many dimensions are there which needs a lot of research and exploration. So you're free to think about it, any use case which you think it can be implemented. By combining big data technologies with ML and AI, the IT sector is continually powering innovation to find solutions even for the most complex of problems. So, when we combine the big data technologies with machine learning and artificial intelligence, we get products like Alexa, right? We get products like Google Home, we are getting chatbots, we are getting personalized assistants by using machine learning, by using artificial intelligence along with the data. An independent AI algorithm is useless if you don't have the appropriate data to find out whether it is working or not. A machine learning based model is useless if you do not have the appropriate data to train that model to find out how it is going to behave in the real world. So big data supports AI and ML. In turn, you can also say that ML and AI support big data. They work interconnectedly together as a whole to satisfy any particular objective of the business enterprises. Talking about the next use case, which is our retail industry. Big data has changed the way of working in traditional retail stores. Over the years, retailers have collected vast amounts of data from local demographic surveys, POS scanners, RFID, customer loyalty cards, store inventory, and so on. Now they've started to leverage this data to create personalized customer experiences, boost sales, increase revenue, and deliver outstanding customer service. Using smart sensors and Wi-Fi to track the movement of customers, the most frequented aisles, for how long customer longer in the aisles, among other things. Social media data to understand what customers are saying about their brand, their services, and tweak their product design and marketing strategies accordingly. So in the retail industry, in the previous lectures also we have used many examples from retail industry. What is happening earlier, those stores used to make their databases in Excel, and they used to do the mappings. If a person is buying bread, then the person is going to buy milk as well, or egg as well, or butter as well. What are the chances to buy that? What are simple probability, simple maths which was being done on your Excel workbooks, on your Excel sheets. But now you have a very big database, right? If you talk about AWS, if you talk about Walmart, you have large databases to find out particular, amount of storage which you need, particular amount of material which you need. You can predict your demand for the next 5 months or 5 years. You can predict how much crunch you're going to go under. You can predict the loyalty of your customers. You can find out what a particular customer likes, what a particular customer is going to buy, what he or she is not going to buy, what are the chances if you launch a product that the person is going to buy. So all of these things, they lead to an increase in the personalized customer experiences. So you give better experience to the customers by leveraging the data which you have stored over the past years. It also boosts sales, it increases the revenue, and it delivers outstanding customer service. Yes. So now there is another dimension to this, where we're using smart sensors and Wi-Fi. So there is one store, I don't know the name of the store, but what they are doing is they are putting RFID tags on each and every product, and these stores are automated. So you go into the store, you pick up the products, you go to the counter, you simply scan those products, and once that RFID is scanned, you can take that product out of the gate, otherwise you cannot. So you pay for the products and you move out of that place. So everything is automated, no human labor is needed, no human management is needed, and everything can be redirected. There is one more paper which was written on the same topic, where it was proposed that you give a handheld device to the person, to the customer who is entering a retail store. On that handheld device, you can simply put your request. For example, if I am asking for a charger, and that store, that device is going to redirect me to the place where chargers are located. Then I want to go and I want to buy a table or a mop. So I can simply put that into my PDA, and that I will be redirected to that section. Another paper was on the similar lines, where it was saying that you can simply put your product which you want, and that product will be bought to you. Maybe I know that I am going to a store with a list of 30 products in my hand. 20 products are set and decided. I need a 1 kg packet of so and so brand sugar. I know that this is what I want, so I can direct that request through my device, and rest of the 10 products in which I need to manually see what I need, what I don't need, for that I can be redirected to my service, right? So these little things, how customers are accessing products, depending upon that you change the demographic area and the arrangement, how products are kept, so that it becomes easier for the user to access stuff. All of these little things, when you're working in business intelligence, when you're working with big data, you try to find out things, you try to enhance the service at all possible levels. And last is social media data to understand. Yes, so you ask them to add you on Facebook, to like them on Facebook. Once you do that, they follow you back, and once they follow you back, you can find out what they like and what they don't like. In many industries, they also launch products depending upon the predictions which they make, whether the user is going to like the product or not going to like the product. Last is transportation. So big data can be used to optimize the route planning, to find out which particular road will be free at what particular time. Maybe at night 2 to 5, some particular patch is empty, and maybe in the afternoon it is empty. So to learn about the traffic related data and to analyze that data to find out the best possible routes for moving, that is one possible explanation or use. To manage road congestion, maybe use the GPS and redirect the traffic to another traffic light if you know that one of it is busy, the way Google is doing, right? Google is accessing the GPS data from millions of devices, and using that data it is predicting all the while which route will be best, which route will be best. Okay, this is blocked, so let's redirect it to some other route. So that is also one possible application. It can also be used in driverless cars, which are in experiment phases right now. So to train those driverless cars, you need a lot of data. You cannot just launch the car in the market. In Australia, they are launching driverless cars. So they are using big data technologies to store data. When a car is running on its own, it is taking pictures, it is trying to understand the environment all on the go. So a lot of data needs to be stored, it needs to be matched to previous similar road sections, so that the car is able to decide कि कौन सा direction लेना है, कौन सा नहीं लेना है, what to do. Either you have to apply brake or to race ahead. So that is another use case for big data working in transportation section. So I used this to design a project. I did a project on this transportation thing where I've tried to find out the shortest path between two destinations depending upon your route covered and depending upon your time taken. So if the time is less on one particular path, you choose it, or if the distance is less, you choose that path. So depending upon those two factors, your distance and your time, I took in data from a lot of devices at any given point of time, right? Maybe for example, you have to go to Prem Nagar from Vidholi, or maybe from Clement Town you have to go to Clock Tower. How are you going to do that? What will be the best possible way? Do you need to take the Shimla bypass road, or do you need to take the other Survey Chalk road? Which route should you take so that you are able to reach your destination with minimum possible effort, right? So for that you will be needing data from the devices which are present all across that network, all across that city, so that you know which roads are congested and which roads are open to move, right? So that is one possible application of big data. That is all for this lecture. Thank you very much.